Hi, I'm Corbin Wildnauer, lead programmer for DuBois Area Robotics Team 1425. Our robot this year is a four-wheel drive base with separate arms on each end, one for manipulating veins and one for working with the surgical tools. There is also a rotating camera on top of the central tower. Our code features three distinct operating modes: a default vein arm mode, a reverse tool arm mode, and an autonomous mode. To simulate and test our code, all gamepad inputs are combined into a signal bus to simplify signal routing. Each bus element was named to match the gamepad to ease coding. The signal bus is then routed with go-to and from blocks. Our IR debug system is only used outside of competition to help adjust and troubleshoot the IR sensors. When activated, LEDs on the cortex are controlled by the IR sensors and light up accordingly. We switch between operating modes using a combination of three buttons. Button 7L is similar to a clutch pedal, in that it must be pressed and held to initiate a mode change. Then the designated subsystem button should be pressed before releasing the clutch. A simple clutch press and release shifts into the default mode. Our drivetrain is a tank drive with slew rates, deadbands, and a speed cut toggle. Custom functions combine these inputs into non-proportional motor signals to increase driver accuracy. Our camera is rotated through a cycle of three predetermined positions based upon degree inputs. The state flow converts the angles to servo positions and begins with the camera pointing towards the vein arm. Our vein arm is controlled by two trigger buttons and two limit switches. The power values are adjustable outside of the state flow. We also included a power boost to help lift the weight of the vein. The vein gripper is controlled by a single button toggle that switches between two specified servo positions in the state flow chart. The wrist on the vein gripper is controlled by three buttons that cycle the wrist between three predetermined positions. In tool arm mode, the vein gripper is automatically opened while the wrist is rotated to neutral, and the vein arm is raised to the vertical position. This keeps the vein arm out of the way and helps avoid accidents. The driver has no manual control of these functions while in this mode. Our autonomous mode centers around three IR sensors, two limit switches, and two potentiometers. When activated, the vein arm and gripper move to neutral positions and the tool arm is raised and held at the correct position to perform the brain biopsy. The tray release is then triggered in case a driver did not already do so. The signals from the IR sensors are combined into a lone signal that is used by the state flow chart to determine how the robot should proceed to the brain cavity. The two potentiometers were originally used to tune our initial motor speeds, but now facilitate small speed adjustments during a competition without any coding changes.